what do we have to know? Well, we need to know quite a number of things when we think about. First of all, is it compatible with that ink, or will it resist against the touch of the ink, or will it swell, or will it destroy? Is it Does it have the proper hardness and thickness for my printing press and my substrate? How about the aspect of the surface? Will it transfer the ink, good or bad? And then what method will I use to create the relief printing elements? And what about the tonal values? Will it be able to hold a very small dot, or for making large solids with a mediocre quality? So our flexoplate has a lot of characteristics to be understood. First of all, the naming. When at school, especially at school with students, I push very much about using the correct terminology. So sometimes there are misunderstanding about what is the relief, the base layer, what is the shoulder of the plate. So we have certain items, certain parts of our printing plate that are named in a particular way. One of these is the shoulder. So when we say the shoulder of a plate, is the vertical wall that describes the relief area. Then we have the floor that is not printing. Then we have the printing surface. We will have a certain hardness or resilience, or durometer, okay, as our American friends are calling. We have a total thickness. Then we have the relief thickness and the base thickness, and then we have a substrate and one component made with another material that is polyester. So if I look at the structure of a photopolymer plating sheets, and here we see the vertical section of the material, we can see that we have the most important part is what we call the body of our photopolymer. This is the area where we will obtain the relief and the printing relief of our printing plate. So, and this will be made with a certain plate making technique and imaging and plate making technique. But then we have one base layer. The base layer is a plastic film, is a polyester film. And why do we have that? Well, we have that because the photopolymer body is a kind of a rubber. So when we mount it, maybe if we stretch it after polymerization, if you stretch it, it gets thinner. So we don't want to lose the advantage of having an accurate thickness of our plate. So we need to have a base layer that keeps the size of our plate undeformed. Then we have another film, another plastic film. It's a protective film. It is a film that we throw away. So it is a film that helps to keep the plate as a sandwich. Okay, it's a kind of a hard sandwich and undeformable. But we remove it and we throw it away when we have to image and process our printing plate. There is one layer, the one you see here marked with the red color. It's a layer that has a multiple function. It has a function of a primer that, let's say, bonds together the body, the photopolymer body, and the base layer, okay, attached. And then it will also provide to have a good adhesion between these two different materials after polymerization. But it has also another function that we call anti-halation layer. What is it? You have seen that we use an ultraviolet radiation, okay? The ultraviolet radiation, when it comes, especially when it comes from the top, it can create certain refraction issues within the thickness of this layer. So in order to avoid that some radiation gets scattered throughout the inner layer of the photopolymer body, this anti-halation layer has the function to absorb the ultraviolet energy, okay? And absorbing the energy, it will avoid to create unwanted enlargement of the shoulders of our printing elements, okay? So the anti-halation provides this function, but it has another function because it can also control the quantity of ultraviolet radiation that will get through the base of our plate when we do one of the most important phases of the creation of the plate, that is the back exposure. So we have a UV radiation that gets through the back of the plate. Between the protective film and the photopolymer body, we have another layer that used to be called the slip coating or slip coat layer. It's an anti-tacking layer. The photopolymer body is extremely tacky, sticky, okay? And in the past, when we used to make photopolymer plates with negative films, you know, when you were putting your film onto the plate, the film could stick, okay, and making it so difficult to move and reposition. Now, this slip coating is a very thin layer of material with a very hard polymerization, okay? So it helps the surface to slip, okay? So if I position any film onto this surface, I can move it freely. But this slip coating over the years, and when we started to have the what's called digital plates, the slip coating is no longer transparent, okay, but it becomes black. So the same slip coating with the same let's say property to avoid the tackiness to be sticky. So you know when you touch your plate with your fingers, you avoid to leave a mark on the surface of the plate. So it becomes black. It is black because it will be the black mask where the laser will image the image on when working directly on the surface of the plate. One interesting thing that you may see also within photopolymer plates is that actually their production is made similar to the liquid photopolymer plate. So the manufacturing of photopolymer plates is made upside down. So we start with the protective film that has a coating, so it's a transparent coating or a black coating onto it, and then onto this coating is applied the thickness of the body, and by means of calendars and an accurate thickness process, we can have the exact thickness of our plate. And after this, they apply the base layer. What will be the base layer? Okay, so the plate is manufactured upside down. Okay, so this is how plates are made, and let's see what are the characteristics of the material. So as you were asking, you know, to understand what are the differences between the different materials, different colors, different hardness. So let's see what are the characteristics that are quite important for us. Okay. And you know, sometimes I go to a printer and I say, I like that pink, the pink plate is good. No, the green one is better because it has a better ink transfer. Oh, but the yellow one has, you know, has a very fantastic resistance. And they speak about colors, and they do not know what's behind the color. Color is just a colorant to create a differentiation of the product on the market. Sometimes the colorant has a certain purpose, but not so frequently. So let's see what are the